In the bone-chilling cold of northern Canada lies a secret that has been buried for 3 billion years. Not gold, not oil, but pristine diamond crystals hidden 600 meters below ancient rock forged when the earth was still burning. To reach this treasure, humans must confront a land where nature barely allows life to exist. Winter lasts 8 months. The sun appears for only a few hours each day, and brutal storms can swallow entire mining camps worth tens of millions of dollars. There are no roads leading and no towns to shelter, and only endless white ice and colossal machines trying to drill through primordial stone. So how did humans manage to crack open the gateway to this giant treasure? Below this storm-ridden story will keep you glued to the screen. Diamonds have long been a cultural symbol, not just for their stunning beauty but for their extraordinary value. In some cases, just a few grams can be worth over $100,000. These crystals were formed more than 150 km beneath the Earth's surface, where extreme pressure and heat shaped them over billions of years. And today, diamonds can even be created from the ashes of loved ones who have passed away, a deeply emotional way to honor and remember them. It wasn't until the late 20th century that this hidden treasure finally revealed itself. Ancient kimberlite pipes began to emerge beneath the frozen bedrock of northern Canada. Open pit mines at Diavik could only reach the shallow layers of ore near the surface, while far below lay a much larger and far more treacherous kimberlite system. At that moment, the ice road became a lifeline. A 400-kilometer ice highway that exists only a few weeks each year, serving as the only route to haul machinery, fuel, and hundreds of tons of equipment into the mining site. This temporary road paved the way for Canada's clean diamond industry, now worth more than $1.6 billion. About 55 million years ago, long before ice swallowed northern Canada, this region was a warm landscape covered in ancient forests and giant ferns. Everything changed when a series of violent volcanic eruptions punched through the Earth's crust, sending columns of magma from more than 150 kilometers below rushing toward the surface. In that chaotic moment, primordial carbon was subjected to extreme heat and pressure, transforming into the first diamond crystals. As the magma cooled, it solidified into kimberlite, sealing the diamonds inside like a geological safe, locked for tens of millions of years, untouched by anything above. And of the more than 5,000 kimberlite pipes discovered on Earth, only 23 contain enough diamonds to be worth mining. They are so rare that they are almost like hidden treasure veins, created by the planet itself, deliberately concealed until humanity happened to uncover them. Millions of years later, in early 2003, Diavik entered its first commercial mining season, and the blasting charges placed beneath the frozen surface of Lac de Grasse marked the moment humans finally touched a legacy the Earth had hidden for millions of years. Hundreds of drill holes, each 10 to 15 meters deep, were packed with ampho explosives. Then the entire site fell silent for a brief second before a deep, heavy boom tore through the air, shaking the ground and sending massive slabs of rock flying upward, exposing ancient layers as if the primordial Earth had just been dragged back to the surface. As the dust settled, 118-ton haul trucks crawled down a 25-meter-wide spiral ramp to reach the newly fractured rock. Each load brought up tens of tons of material, though most of it was nothing more than lifeless granite. What the miners truly hunted were the dark, narrow streaks of kimberlite, the only part of the formation capable of hiding diamonds, once carried upward by magma from 150 kilometers below. Once brought to the surface, kimberlite entered a harsh series of processing stages, each step stripping away another layer of mystery buried within the ore. Sometimes several tons of rock had to be crushed, washed, and sorted just to recover a single diamond no bigger than a pea, perfectly reflecting the brutal and improbable journey it endured over 55 million years beneath the Earth's surface. As the kimberlite near the surface was gradually exhausted, the hunt for diamonds had to push deeper underground, reaching directly into the heart of the kimberlite, where the most valuable crystals still lay hidden. Here, massive crushing machines were brought in, tearing huge blocks of ore into pieces small enough to process. Yet the diamonds remained untouched. Their near-perfect hardness allowed them to survive every crushing force without a single scratch. The remaining rock then moved through a series of separation stages, each stripping away more of the surrounding material and bringing the crystals closer to daylight. After tens of millions of years locked in darkness and stark contrast to the storm-blasted world above the air, underground stayed at a steady 15 degrees C for many workers. This cramped and dim space actually felt safer and warmer than the 50-degree C Arctic temperatures on the surface. In the deepest levels, specialized haul trucks carrying nearly 400 tons of ore rumbled through tunnels barely wide enough for a single lane. Every vehicle had to stay in constant communication with the control center to avoid collisions inside the pitch-black maze stretching for kilometers. Even though the tunnels and steel crushers could reach deep into the earth, Diavik still depended on a single lifeline running across the ice. Each winter, when the Arctic grew cold enough to freeze dozens of lakes into a sheet of glass more than a meter thick, the 400-kilometer temporary route appeared the only gateway connecting the mine to the outside world. During those brief few weeks, nearly 7,000 trucks carrying fuel, cement, steel, and heavy equipment traveled across the ice, bringing everything needed to keep the underground operation alive in the middle of the frozen wilderness. When the 400-ton trucks emerged from the underground tunnels, the rock freshly escaped from tens of millions of years in darkness entered its first stage of liberation. Kimberlite isn't sent straight to the central plant. It goes to an on-site crushing station where the raw ore is screened for the first time to separate anything valuable from the useless waste rock. Inside the station, steel machines weighing tens of tons act like giant mechanical jaws, capable of pulverizing granite as hard as metal in seconds. But that power can't be used carelessly. Diamonds, despite being the hardest natural material on Earth, are incredibly brittle. A single crushing force slightly above the design threshold can shatter a crystal into dust and erase its entire geologic history. So the crushing force is tuned with near-surgical precision, strong enough to break the host rock, yet gentle enough to keep the hidden crystals intact. The ore moves through multiple stages, slow compression rolling crushers, and vibrating screens, each stripping away another layer of shell surrounding the diamonds and bringing them closer to freedom. Once the ore had been reduced in size, the material stream moved to the cleaning stage, where the last traces of mudclay and mineral dust were stripped from the rocks. Inside continuously rotating trommel drums, the ore tumbled against steel walls, while high-pressure water jets blasted through every crack, leaving behind bare mineral surfaces. Any particles smaller than 1 millimeter were removed immediately, as their chance of containing diamonds is virtually zero. The remaining material passed through a series of screens to sort it by size, forming a concentrated stream containing the most valuable fraction. On a sealed conveyor belt, X-ray sensors began scanning the flow. Diamonds with their distinctive fluorescence under X-rays flashed brightly among thousands of dull stones. In a fraction of a second, a burst of compressed air shot each diamond into a separate recovery chamber. Material that didn't trigger the X-ray sensors but still showed the right physical characteristics was sent to the gravity separation system. In a ferrosilicon slurry, ordinary rock floated away while the denser fraction, where many hidden crystals still remained, was held back. When the final concentrate was separated, only the hardest, most durable minerals were left, and among them the diamonds finally began to appear. The final stream of material leaving the recovery systems moves directly into the sorting room, where the crystals, newly freed from rock after tens of millions of years, are examined by human eyes for the very first time. On color-calibrated light tables, each rough diamond is spread out and rotated under magnification to reveal its natural structure. Size, hue, clarity, crystal shape, every detail is recorded with precision. 3D scanners and optical tools help generate models, but the final judgment still comes from the experts. From this stage, the diamonds split into two distinct pots. Stones that are clean, stable in structure, and large enough are sent for jewelry cutting. The rest are designated for industrial use, destined for ultra-hard cutting tools and drill bits. Each diamond enters the cutting planning stage like its own personal surgery. The crystal's natural shape is scanned into a 3D model, revealing every facet, inclusion, and fracture. Once the cutting plan is finalized, the diamond is opened with a high-powered laser. The polishers then shape each facet using diamond-coated wheels until the stone reaches perfect brilliance. Once finished, the diamond enters grading, where its color clarity and carat are measured. A laser inscription gives it a permanent identity. Certified by organizations like GIA or IGI, the diamond becomes fully traceable. Finally, it enters the hands of master jewelers, who transform it into rings, necklaces, and heirlooms. From ancient rock buried deep beneath the Arctic to the bright lights of jewelry showcases, every diamond carries a journey longer than human history itself.